Understanding the difference between JVM, JRE, and JDK. This is the most common point of confusion amongst the Java developers. To understand this difference, I want you to visualize JDK, JRE, and JVM as three different containers, and we'll look onto each container separately. So, starting with the JDK container, so that you have this text here, right? So, think of this text. What essentially it is a text. So, what difference is going to occur when you write a main.txt file and you write a main.java file? What is the point of difference and what makes the Java code as the Java code? So it is the JDK, that is the Java Development Kit, that allows you to convert the main.java file to recognize it as a code and let it and compile it into main.class, which you can run as a program. Now arises our second question, the program. So do you need a Java development kit to run the program? Because not everyone is not a developer. So the answer for this question, the running of a program is done by the Java runtime environment, and the Java runtime environment is available at nearly all the devices, and it is provided by the device providers, that is the or the OS providers itself. It is a hardware level thing, and it uh, in our case we can ignore the main.java, that is the running of the code, and we can directly compile the class file into the program. This can be done using the Java runtime environment. But now, after talking about the different hardwares, then will the running of the main.class file has it some relation with the hardware or the device or the operating system you are using? So to answer this question, let me introduce to you the Java virtual machine. So the flow till the main.java to the main.class remains the same. The difference that takes place is from the main.class to the run execution of the program. But before coming to this, let me explain what a bytecode is. So most of the people consider it as the zeros and ones, which is wrong. Consider bytecode something in between your Java code and zeros and ones. It is a middleman for your Java code and the underlying hardware. So each of the operating system has its own JVM, which is used by the uh, program for executing the class file. Let us summarize all these three containers into a single common picture. So it would look something like this. What I uh, what I mentioned about JDK, it is the development kit. So all the Java compilers, the JRE, the debuggers, all of this comes into JDK as the development kit provided to the developers. Then comes the Java runtime environment, JRE. It has the JVM, the class, the libraries which you use and which is used for running the program. Then comes the JVM. Each of the operating system has its own JVM, uh, has its own way to run the different programs of the Java files. Now I have a bonus section for you. The bonus section is the JVM architecture. So this is how the JVM architecture looks like. I want you to understand each of the component of the JVM architecture one by one. So talking about the method area, what the method area essentially is, it is the place where all the instantiation or the initialization that you do of the classes is happening over here. Then comes this heap. Heap is where the instance memory is stored. Consider you declare a variable, you assign it a value, where it is getting stored. The location is heap. Then comes the stack. A common thing people would have heard is Stack Overflow, isn't it? So think of Stack as a pile of books. Essentially, what it does is that it stores your method local variables, and also it is for one thread you can only have one stack, and when that stack gets exhausted, that is when the Stack Overflow error occurs. Okay, okay. Let's now go to the PC register. So you have got different bytecodes. It maybe some 10 or 20 bytecodes, but who decides which bytecode has to come first? So PC register has those instructions that will decide which bytecode is going to come. That is the sequence of the execution of the bytecode is decided, and it is stored in the PC register. Then comes the native method stack. So essentially, the Java program you write, it may be using some native methods from C or C++. So to call those methods, we have the native method stack. Then comes the execution engine. All these things that you have seen are done executed using the execution engine and the native method interface. So as we discussed about the native things that we are calling in our code, to allow the calling of those native methods or libraries, sorry, not libraries, because it is covered by the native method libraries. To allow calling of it, we have the native method interface that allows the Java program to call code from the native method stack. And then we have the native method libraries. So what native method interface it is that you are using some piece of code that is written in C or C++. But the difference between this and the native method library is that the libraries at your hardware level, that is the networking or the graphics, all of this is written in the native language, C or C++. So to use the networking module or the graphics module, we have the native method libraries. And this sums up our discussion for the JVM, JRE, and JDK. That's all for this video.